Hello class, these are going to be your notes over your energy and wind and how they relate to the earth. We're going to look at these in 5 different sets. The first part, we're going to look at the different ways that our earth gets its energy. Now the source of all the energy that we're going to have here on earth comes from the sun. And when the sun's energy gets to the earth, 3 things happen. Some of the energy comes in to earth and it gets reflected back into space. So it kind of bounces off. Bounces. The second thing is that some of them, as we've learned, gets absorbed by the ozone layer into the atmosphere. The last thing that happens is that whatever energy gets through the atmosphere, it gets absorbed by the land and the water. Now we're going to look at 3 different components of how this energy can interact in the environment. The first one is what's called radiation. Radiation is the transfer of energy by what we call electromagnetic waves. Electromagnetic waves are just energy waves that are going to travel in a wave-like fashion. So they're your usual things that go woo, 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 woo. Those are your electromagnetic waves. And there's 2 ways that you actually experience this here on Earth. They are in the form of heat and in the form of light. So 2 things that we're already kind of familiar with from some of the things that we've done in class as far as our seasons go. Now how do we absorb the heat? We absorb the heat as what's called radiant energy. It comes from it's the radiation portion of it, so it's called radiant energy. And what we have is that the molecules that are in our skin or on our hair, they're actually going to absorb that heat and absorb that light. Just like the ozone layer absorbs it, the molecules that make up our skin and make up our hair and make up whatever are going to be absorbing that same heat and that same light. Now the direction that heat typically moves at is it goes from a higher temperature to a lower temperature, because the way that natural things want to do is they want to try to balance things out in the world. So it wants to go from an area of high concentration to an area of low concentration to kind of balance things out. So we got kind of the middle of the road there. So if it's really hot in one area and really cold in the other, the hot is going to go to the cold and kind of even them out. Now one thing that happens when the ozone layer absorbs that ultraviolet radiation, or the radiation that we get from the sun, is that the temperatures begin to rise everywhere on Earth. The second form of how the Earth gets its energy is through conduction. Now what conduction is, it's when we have our different molecules and they're bumping into each other. When they're bumping into each other, every time they bump into each other, they're transferring energy. So when 2 things touch each other, there's going to be a transfer of energy. An example of this is like when it's a hot day and you're walking on a beach or maybe a road and you take off your shoes and your foot touches the hot sand or the hot asphalt or concrete. Your foot's going to get hot. That's conduction. The molecules are bumping into each other. In this case, the molecules from the sand are bumping into the molecules of your foot, and it's causing the energy to transfer. Since heat wants to go from an area that's hot to an area that's cold, you are going to feel the heat in that case, because the heat is being transferred from the ground to your foot. So what you would feel is the hotness coming off of it. So in general, when molecules get hot, they start moving really fast. So they're bouncing around everywhere. That's what makes them hot. They're going to go to the ones that are moving more slowly, which are going to be our cold molecules. So how energy gets transferred in this case is that the hot molecules are going to give some of their energy to the slower forming molecules, and they're going to just kind of balance themselves out, so they're in some kind of medium kind of movement. They're in between that hot and the cold. They're going to try to balance each other out. So hot means fast, cold is slow. Just kind of how you might think other things might work. Now the last one that we're going to take a look at is convection, which is the transfer of heat, specifically, by the flow of heated materials. So it's how heat is going to be circulated throughout our environment and throughout our atmosphere. The 2 things that it works with are gases and liquids. So no solids are going to be involved with this one. Now what happens to molecules when they are warm is that in general the molecules are going to start moving apart. As they move apart, they're going to increase their volume because they're getting bigger. Their volume is increasing. As their volume increases, the density of them, since they're moving apart, their density will become less. Because their density is becoming less and they're spreading themselves out, the air pressure will also be lower when it's warmed up too. So because of all this, the air is going to rise when it's warm. The opposite happens when things are chilled. When things are chilled, they're going to start to huddle up. Just like when you're cold, you kind of huddle up for warmth. Same thing is going to do with our air molecules. They're going to huddle up, move closer together, meaning that they're going to be more dense. They're going to be, they're going to have, their volume isn't going to be as big because they're all clustered together, and the air pressure is going to be greater because they're all tightly, constricted together. So what happens is that because of all this, the warm air rises and the cold air sinks. And this causes our movement of the air, because as the warm air rises, it's going to get a little bit colder. As it gets colder, it's going to sink, it's going to get back warmer. So it creates what we call convection currents, where the warm air rises and the cold air sinks and we get the circulation of the air. We're going to look at that in a couple of different ways when we look at some of our sea and land breezes a little bit later. In the second section of our notes, we're going to look at the water cycle. Now, the water cycle is something that you're probably already familiar with. Either you've learned it in the past or you've talked about it a little bit in geography already this year. Now, with our water cycle, we got to notice that we have another sphere term to add to it. It's called the hydrosphere, which represents all the water that is on Earth. The Earth is mainly a water planet, so it's likely that it's given its own spherical name there. Now, when we talk about the water, a majority of the water that is on our planet is actually in the form of salt water. About 97% is salt water, meaning 3% is going to be fresh water. Fresh water is the stuff that we need because that's stuff that we drink. If we drink salt water, we'd actually become dehydrated. As far as the water cycle goes, for a more in-depth diagram of the water cycle, check out the EduCreations video that I posted. That way you can see the actual drawings of it. Here I'm just going to talk about some of the terminology that is involved with the actual diagram. The first thing we have is evaporation. That's when water turns into water vapor by heating it up. So it goes from liquid to a gas. We then have condensation, which is where we get our water vapor turning back into a liquid water. Usually get clouds to form at that point too. So as the evaporated water vapor goes up, it starts to form the clouds. Those clouds are going to be condensation. It turns the water vapor back into liquid water. Precipitation is where the moisture falls from the clouds, so we get rain, sleet, hail, snow. It's where we get the moisture to fall. And then there's two things that happen to water once they reach the ground. We have what's called runoff, which is where the water doesn't get absorbed in the ground, and that's what causes, the streams and the floods. It's the water that builds up on top of the ground. It can travel in the rivers, the streams. It's going to eventually lead itself back to the ocean. The stuff that does get absorbed into the ground is what's called groundwater. That's the stuff that's going to go deep inside the ground. Plants can soak it up. Eventually it might lead to some underground rivers that will eventually trickle down back into the ocean. But that's the stuff that's going to get into the ground is called your groundwater. The next thing that we're going to look at is what's called the Coriolis effect, which is really how our winds form and the reasons why our winds blow in the different directions that they do. The first reason for how wind is actually formed is because of the uneven heating on the Earth's surface. Now, when we looked at seasons, we learned about what causes the uneven heating of the Earth's surface, because that's the reason why we have our seasons. But that's also the reason why winds are formed, because the Earth is unevenly heated. It causes warm air and cold air to be in certain places, and as we looked at with those convection currents earlier, that causes the air to move in kind of these cycles. So once again, to refresh ourselves, the warm air is going to rise up. As it rises up, it's going to cool down a little bit. As it cools down, it's going to sink. And then that all is going to go around and around and around and around, and it's going to create this little cycle. Typically, we get our warm air from our equator. It's one of the warmest spots on Earth. And we're going to get our cold air from the poles. So it also is going to be traveling from the middle to the outside and back to the middle and out to the outside. It has a cycle to it, and we'll look at a couple of these different cycles in a little bit too. Now, the cause of the temperature differences is because of the fact that we do have our different seasons, and the Earth has the tilt to it, so different places are exposed to different amounts of solar radiation. That's the sun's energies. Because of that, this causes the temperature differences that we see. So overall, what happens to the cold and warm air is that the cold air is going to be more dense, meaning that they're more jam-packed. Remember, they're all squished together. When they're cold and dense, they're going to be heavier. So that's going to want to sink or push down. As they're pushing down, they're actually pushing down on some of the warmer, less dense air, because that's getting heated up by the land and the water. Because remember back when we get the land and the water absorb some of that leftover heat that gets through the ozone layer. And that's going to cause that warmed up air to increase or to rise up. When they rise up, they're going to go back down, and we have these patterns that develop. One of the things that also goes along with our wind is what is actually called the Coriolis effect. And this is caused by the rotation of the Earth. And because the Earth is rotating, spinning, it's going to cause our winds to spin with it, to move in different directions. So what the Coriolis effect is that it deflects all of the free-moving objects. So that's wind and water, the stuff that isn't actually physically attached to the Earth. It's going to move objects in the northern hemisphere slightly to the right, and it's going to move the objects in the southern hemisphere slightly to the left, and that's because of the way that it's rotating. As you're rotating, things are not going to go straight, they're going to be curved a little bit. So that's what's happening to our air and our water, is that the Coriolis effect actually curves it a little bit as they're moving closer to the equator, whether they're from the northern hemisphere or the southern hemisphere. So the effect that they have on air movement is that if you're in the northern hemisphere, which we are, as airs are moving back down towards the equator, they're actually going to be moving a little bit west. So as I also mentioned, it's what creates our wind patterns that we also have on Earth. Part 4, we're actually going to look at these different wind patterns that we have on Earth. The first thing that we're going to mention is what's called a doldrum. And these are actually the windless zones where you're not going to get a whole lot of wind movement. These are typically located at the equator. Going from the equator, we have a series of 3 sets of winds. The first set of winds that go from the equator to about the 30-degree mark, moving north or south, is what are called the trade winds. And in the northern hemisphere, these are winds that are going to blow to the southwest. Go to see the Educreations video to see a diagram of how these move. But they're going to blow southwest in the northern hemisphere, northwest in the southern hemisphere. And typically the direction that they're going to be blowing is back towards the equator at that point. The next set of winds, we have the prevailing westerlies. And these are winds that blow the opposite to the trade winds. So they're going to be going in the opposite directions. These are located between the 30-degree mark and the 60-degree mark on our globe, going north and south. These are primarily used for, and the reason why these are important, because these are the winds that we are located at in the United States, in North America. And these prevailing westerlies are the things that decide how our weather moves in the United States. By tracking these weather patterns, the meteorologist can determine what weather is coming our way. The last set is the type of winds that are at the poles. These are from the 60-degree mark up to the poles. And they're the last major set of our wind currents. When we compare them back to and these are called the polar easterlies. Now when we compare them back to the westerlies, these are going to be moving in opposite directions from the westerlies, but they're going to be in the same direction as the trade winds. So if the trade winds go in this direction, so will the easterlies. The westerlies that go in between them would go in the opposite direction. And these is what causes our patterns of circulation of the wind on Earth. Now there's one other thing that we can look at, and those are what are called jet streams. These are strong, powerful winds right at the top of the troposphere, at the very edge of the troposphere to the stratosphere. And these are going to be very strong winds that in some cases can help airplanes navigate a little bit easier, make them not use as much fuel, or they're things that pilots want to avoid because they might cause them to use more fuel. So these are very strong winds that are also in our atmosphere, the jet streams. Our fifth and final objective that we're going to look at is land and sea breezes. that you can experience is caused by our convection currents. Remember, our convection currents are the things that let warm air rise and cool air sink. Sea breezes is what happens during the daytime. They're created because the solar radiation warms the land more than the water. So to see a diagram of how this happens, go check out the Educreation videos that I have posted. These typically occur during the daytime. For the land breezes, they're the opposite. The cool, dense air from the land starts to go out into the water. As they're going out over the water, the warm water, now that after it's been capturing the sun all day, is going to warm up the cool air and going to force that upwards. This is what typically occurs during the nighttime. Similar types of things happen in our mountainous regions. And for a mountain, you have your actual mountains, and then you have the valleys. Those are the areas between the mountains. In the morning, sunrise, the valley winds are going to be going upwards up the mountain. When it is nighttime, the mountain winds are coming to come down the slope into the valleys. These cause our heating of our mountains to be both cold and warm during different parts of the day. At nighttime, the valleys are going to get very cold because the mountain winds are coming down. During the day, the valleys are going to be kind of pleasant because you're getting the sun's energies at that time. So it all depends on how the wind is moving in the mountainous valley regions. Now the seasons and how they affect winds, these are more of what we're going to be dealing with. In the winter, obviously, the land is going to be cooler. We get our colder temperatures. So what happens is that the air kind of flows away from the land. It's going to go to wherever the nearest bodies of water are, because the water is still going to be absorbing more sunlight than the land does at this point. The land's going to be a little bit cooler. So the airflow is going to flow away from the land. During the summer, it's the opposite. The land is warmer, the air is going to want to flow towards the land. So you might get that nice sea breeze to cool you down, or why people go on vacations to beaches during the summer, because they get that nice wind coming off of the body of water hitting them. It's a nice combination to go along with the nice sun. Once again, make sure you check out the Educreations videos as well to see some diagrams and some further explanations where I can actually draw some stuff out for you. Remember, these notes are going to be due on Monday. Always remember, you can find all this information from your book.